In this installation, a neutral is not typically required for the 480/277 volt Y to 208/120 volt Y step-up transformer. The XO/HR terminal, which is the welded bus common connection, can be grounded without a neutral connection. Here's the reasoning. The factory furnished 208/120 volt Y to 480/277 volt Y step-up transformer is designed to provide isolation between the input and output circuits. The transformer creates a floating neutral on the secondary side, the 480/277 volt Y, which means that the neutral point is not connected to the primary or ground. When the XO/HO terminal is grounded, it establishes a reference point for the 480/277 volt Y system on the secondary side of the transformer. This grounding provides a path for ground fault currents to flow and ensures the proper operation of the UPS and connected equipment. The neutral connection on the primary, the 208/120 volt Y, side of the transformer is grounded at the main service for the facility. This grounding ensures that the primary neutral is at zero potential and provides a reference for grounding the secondary neutral, the XO/HR terminal. Therefore, in this specific installation, a neutral connection to the XO/HR terminal is not necessary. The grounding provided by the XO/HR terminal connection and the neutral grounding at the main service are sufficient to establish a reference point and ensure safe operation of the system. The purpose of the step-up transformer is to increase the voltage from a lower level, in this case 208/120 volts, to a higher level, 480/277 volts. This is often done to supply power to equipment that requires a higher voltage than what is readily available. A Y-connected transformer has a neutral point, which is the common connection of the three windings. In a 208/120 volt Y system, the voltage between any phase and neutral is 120 volts, and the voltage between any two phases is 208 volts. In a 480/277 volt Y system, the voltage between any phase and neutral is 277 volts, and the voltage between any two phases is 480 volts. The XO/HO terminal is the neutral point of the secondary winding, the 480/277 volt Y side of the transformer. Grounding the XO/HO terminal provides a path for fault currents to flow back to the source, which is necessary for the proper operation of overcurrent protection devices such as circuit breakers and fuses. Without a ground connection, fault currents may not be high enough to trip the overcurrent protection devices, which could result in damage to equipment or even a fire. The National Electrical Code, or NEC, provides specific requirements for grounding electrical systems. NEC Section 250.20 requires that alternating current systems of 50 volts or more that supply premises wiring and equipment be grounded. This requirement applies to both the primary and secondary sides of the transformer. NEC Section 250.30 provides requirements for grounding separately derived systems, which includes transformers. This section requires that the neutral point of a separately derived system be grounded, unless certain conditions are met. One exception is that a separately derived system is not required to be grounded if it supplies only equipment within a single building or structure and the system has a maximum line-to-line voltage of 150 volts or less. In this case, the 480/277 volt Y system is a separately derived system, but it does not meet the exception because it has a line-to-line voltage of 480 volts. Therefore, the neutral point of the system must be grounded. However, NEC Section 250.30 also allows for the XO/HO terminal to be grounded without a neutral connection as long as certain conditions are met. One condition is that the grounding impedance must be low enough to limit the voltage to ground to 30 volts or less. This can be achieved by using a grounding electrode conductor that is sized according to NEC Table 250.66. Another condition is that the grounding electrode conductor must be connected to a grounding electrode system that meets the requirements of NEC Section 250.50. This section requires that the grounding electrode system consist of one or more of the following electrodes: a metal underground water pipe, a metal frame of the building or structure, a concrete encased electrode, or a ground ring. In this installation, the neutral connection on the primary side of the transformer is grounded at the main service for the facility. This grounding provides a reference for grounding the secondary neutral, the XO/HO terminal. By grounding the XO/HO terminal, a path is created for fault currents to flow back to the source, which is necessary for the proper operation of overcurrent protection devices. Additionally, grounding the XO/HO terminal helps to limit the voltage to ground, which reduces the risk of electric shock. The size of the grounding electrode conductor is determined by NEC Table 250.66, which is based on the size of the largest ungrounded conductor. The grounding electrode conductor must be connected to a grounding electrode system that meets the requirements of NEC Section 250.50. The grounding electrode system must consist of one or more of the following electrodes: a metal underground water pipe, a metal frame of the building or structure, a concrete encased electrode, or a ground ring. It's important to note that the grounding requirements for electrical systems can be complex, and it is always best to consult with a qualified electrician to ensure that the system is properly grounded. The electrician will be able to assess the specific conditions of the installation and determine the best grounding method to use. Furthermore, local codes and regulations may have additional requirements that must be followed. In summary, for this specific installation involving a 208/120 volt Y to 480/277 volt Y step-up transformer, a neutral connection to the XO/HO terminal is typically not required. Grounding the XO/HO terminal provides a path for fault currents to flow back to the source, which is necessary for the proper operation of overcurrent protection devices. Additionally, grounding the XO/HO terminal helps to limit the voltage to ground, which reduces the risk of electric shock. The grounding electrode conductor must be sized according to NEC Table 250.66, and the grounding electrode system must meet the requirements of NEC Section 250.50. However, it is always best to consult with a qualified electrician to ensure that the system is properly grounded. There are some potential downsides to not having a neutral connected to the XO/HO terminal. Firstly, it can make it more difficult to detect ground faults. Without a neutral connection, ground fault currents may be smaller, which can make them harder for ground fault protection devices to detect. This can increase the risk of damage to equipment or even a fire. Secondly, it can increase the voltage to ground. Without a neutral connection, the voltage to ground on the secondary side of the transformer may be higher, which can increase the risk of electric shock. Thirdly, it can make it more difficult to balance the load on the transformer. Without a neutral connection, it may be more difficult to ensure that the load on each phase of the transformer is balanced. This can lead to overheating and damage to the transformer. In some cases, it may be necessary to install a neutral reactor to limit the ground fault current. A neutral reactor is a device that is connected between the neutral point of the transformer and ground. The reactor limits the amount of current that can flow in the event of a ground fault, which can help to protect equipment and reduce the risk of electric shock. The size of the neutral reactor is determined by the size of the transformer and the amount of ground fault current that needs to be limited. It is important to note that the installation of a neutral reactor can be complex, and it is always best to consult with a qualified electrician to ensure that it is properly installed. Another option is to use a zigzag transformer to create a neutral point. A zigzag transformer is a special type of transformer that is designed to provide a neutral point for a three-phase system. The zigzag transformer is connected to the three phases of the system, and the neutral point is connected to ground. This provides a path for ground fault currents to flow back to the source, which is necessary for the proper operation of overcurrent protection devices. The zigzag transformer also helps to limit the voltage to ground, which reduces the risk of electric shock. The size of the zigzag transformer is determined by the size of the system and the amount of ground fault current that needs to be limited. It is important to note that the installation of a zigzag transformer can be complex, and it is always best to consult with a qualified electrician to ensure that it is properly installed. Furthermore, it is crucial to verify that all equipment connected to the 480/277 volt system is rated for that voltage. Connecting equipment rated for a low voltage, such as 208/120 volts, can result in equipment failure, fire, or electric shock. Also, it is crucial to ensure the overcurrent protection devices are properly sized and coordinated. This includes circuit breakers and fuses. The overcurrent protection devices must be able to interrupt the fault current without causing damage to the equipment or the system. Proper coordination of the overcurrent protection devices ensures that the device closest to the fault will trip first, minimizing the extent of the outage. In addition, it is important to consider the impact of harmonics on the system. Harmonics are currents or voltages with frequencies that are multiples of the fundamental frequency of the system, which is typically 60 Hz in the United States. Harmonics can cause a variety of problems, including overheating of equipment, increased losses, and interference with communication systems. If harmonics are a concern, it may be necessary to install harmonic filters to reduce the level of harmonics in the system. Regular maintenance and inspection of the transformer and grounding system are also important. This includes checking the tightness of connections, inspecting the insulation for damage, and testing the grounding system to ensure that it is functioning properly. Regular maintenance and inspection can help to identify and correct problems before they lead to equipment failure or safety hazards. In conclusion, while a neutral connection to the EXO/HO terminal is not typically required for a 208/120 volt Y to 480/277 volt Y step-up transformer, it is important to carefully consider the specific conditions of the installation and consult with a qualified electrician to ensure that the system is properly grounded and protected. If there are concerns about ground fault detection, voltage to ground, or load balancing, it may be necessary to install a neutral reactor or a zigzag transformer. And remember, always prioritize safety and follow all applicable codes and regulations.